Math 102, example 1.7.1. As we look at the details of graphs, the first thing we're going to talk about is continuity. Now this is an informal definition, but it's the one we'll use for this class. We say a function is continuous if you can draw that graph without lifting up your pencil from the paper. So looking at our first one, I can draw that entire shape without picking up my pencil. So I would say that that is continuous everywhere. Now I usually want to write this as an interval. So as an interval, I would express that as negative infinity, comma positive infinity. Now my next drawing, there's a problem. Here at -2, something is happening. We'll learn later in the class what exactly that is. So this is continuous everywhere except at x equals -2. So basically everything except a single point. To write that as an interval, I'm going to express it as negative infinity to -2, and then -2 to positive infinity. That little u symbol in the middle is our formal way of writing or, and that's what we usually use if we have two intervals that don't connect. Let's scroll down to my next one. Once again, something weird has happened here. This time, something's happening at +3. So it's continuous everywhere except at +3. So I would write that as negative infinity to +3. Again, that little u means or, and then +3 to positive infinity. So once again, I get two intervals for my answer. Scrolling down to the very last problem. This, I don't have arrows on the two ends. I've got closed circles. So I have both a stop point and a start point. So here, we start at -2 and we end at +2. Now I am including those endpoints, so I'm going to go ahead and put brackets, or closed square brackets there. If that looks familiar, we did this exact same problem a few sections ago, and that was our domain. In this class at least, the intervals of continuity and the domain are basically the same thing.